You've just provisioned a fresh Linux VPS, likely running Ubuntu 22.04 or Debian 12, and you are staring at an empty terminal. Your immediate instinct is to start pulling images and firing off single applications using standard Docker run commands, but you have to decide exactly when a simple development experiment needs to evolve into a structured architecture. Deciding between the plain Docker command line and Docker Compose depends on your specific operational requirements, not the number of containers you're launching. It comes down to whether you are launching an isolated process or defining a fully reproducible, operable system. Picking the wrong operational level leads to chaotic documentation, broken service connections, or a setup that is severely overcomplicated for your actual needs. Starting from a new Voxfor VPS, we must map out exactly which tool to use and the required server power based on your workload. Aligning software architecture with the right hardware tier ensures your VPS handles the specific memory and CPU demands. Let's start with the input of using plain Docker run commands for a single, stateless application, such as a basic static web server. The outcome is an immediate, low-friction deployment. You bypass the need to write or manage any configuration files. This introduces a fragile trade-off. If your server restarts, you are forced to remember the exact messy string of command line flags you used to recreate that container. This specific workflow fits absolute beginners learning the basics, or system admins running a single reverse proxy. Because plain Docker is optimized for raw execution rather than system documentation, it remains inherently unscalable for complex projects. When your application requires multiple connected containers, such as an app, a database, and a proxy, you transition to Docker Compose. This requires a physical shift. You move from typing terminal commands to writing a declarative YAML configuration file. The primary architectural outcome is that Compose automatically provisions a default bridge network for your entire project. This bridge network diagram shows how Compose provides service name DNS discovery out of the box, eliminating the need for you to manage manual IP mapping. The operational trade-off is that Compose requires an upfront investment in learning YAML syntax and mapping out your dependencies. Doing that upfront effort permanently eliminates port mapping errors and chaotic shell scripts, making complex deployments fully repeatable. Within that Compose configuration, you add persistent data by defining named volumes. As a result, your data survives container recreation and bypasses the slower storage driver abstraction layer for better performance. The strict trade-off here is permanence. Explicitly deleting the volume via the command line will permanently and irreversibly wipe your database. Utilizing persistent volumes shifts your administrative burden from managing containers to executing deliberate, scheduled backup strategies. All of this software has to map to your hardware tier, starting with starter plans like the Voxfor Vox32. A Vox32 provides sufficient baseline CPU and RAM for a starter app, a reverse proxy, and learning environments. This capacity chart reveals the limitation. Starter plans bottleneck immediately if you task them with heavy background workers or large continuous integration pipelines. To support those workloads, you have to input a larger hardware tier, sizing up to a Vox42 or Vox52 plan. This yields the massive memory reserves necessary for robust Compose stacks, heavy databases, and self-hosted CI runners. Hardware scaling must be justified by genuine production needs, which prevents you from overbuying resources or under-architecting your systems. Transitioning to production requires addressing severe operational risks, specifically regarding the Docker Daemon API. You should never leave the Docker API exposed over a TCP socket without TLS safeguards. This configuration grants attackers effective remote root access to your entire VPS. Stick to the default Unix socket to guarantee baseline security. You also need to switch your daemon log driver from its default format to the local format within your configuration file. The local format enables automatic log rotation, preventing noisy containers from silently exhausting all available disk space over time. True production readiness requires prioritizing system defense and resource management over mere application deployment. The choice between Docker and Compose is entirely determined by the required level of operational abstraction. This decision matrix breaks down 3 exact profiles. First is the learner, who needs plain Docker for single, stateless apps, paired perfectly with a Vox32 instance. Second is the app builder, deploying interconnected web stacks and databases, requiring Docker Compose on a Vox42. Third is the heavy hoster, managing self-hosted CI or dense environments, requiring Compose with strict hardening on a Vox52 or higher. There is a final rule of thumb regarding your deployment documentation and operational friction. If your personal deployment notes mutate into a massive paragraph of run flags, you have definitively outgrown the command line. Stop using plain Docker at that exact tipping point and immediately move to Compose. Plain Docker handles the low-level execution of your containers. Moving to Compose creates a self-managed system that remains reproducible as your requirements grow.